Here is a solution for problem doing container shuffle. In this problem, we are given a ship which has n containers, numbered from 1 to n, from left to right, and then it's first moved to the storage, which contains of 2 stacks of containers. Each container is randomly moved to either first stack or the second stack in the order. For example, like it's shown in the picture. And then they need to be moved to the tracks in the given order. First container number A1, then container number A2, and so on. We are asked in what is the average number of moves we need to do to the whole move, averaged by all ways, all 2 to the n ways of moving, of separating containers between 2 stacks. To put the container A1 on the track, we need to make it top one of the stacks. For example, if we need to move container 3 in this way, we need to first move container 4 to another stack. So the key observation we can do here is if we first number containers from the left stack from bottom to the top, and then containers on the right stack from top to the bottom, this total order would never change during the hour process. The only thing which would happen to this order is some containers would eventually disappear. So for example, if we move container 4 to the right and then remove container 3, then we would have almost the same order, except the fact that there is no more container number 3. Assuming that, we can count number of moves we need to do in each step, and based on linearity of expected value, we can just sum these values, and this will be the final answer. If we want to count average number of moves we need to do to finish each next container, we need to figure out in what state our stacks would be right after we start moving it. But we know it as our values didn't change, order of our values didn't change, and we know which stack was on the top before. So we have this previous one, for example, let it be A2. There would be some containers before it, some containers after it, then our A3, and some other containers after it. Then we know that this part would be the left stack, and everything else would be the right stack. So we know, as we know the container, we know, and as no stack arrangement, we know which containers need to be moved. These are exactly containers that are between A1 and A2 and A3. So basically, we need to compute number of containers between each of consecutive containers to be removed, and sum all these values, and that would be the answer. And to compute this value, we can again use the linearity of expected value and just sum the probability of each container being between these two. It occurs that this is actually a very simple value. If this container if number of this container is smaller than both of previous one and this one, it can never be between them. Indeed, when both of these containers are placed, it was already placed, so it would be either under one of them if it's there in different stack and this is not between them, or it would be above both of them, which is also not between them. On the other side, if it's bigger than both of them or in between of both of them in sense of value, in sense of index, then the probability would be exactly 1/2, which can be shown by some casework. So basically what we need is to count number of values, is to sum over all number of values that are greater than minimum of AI and AI minus 1, and not before this, and not already removed. And then we need to divide it by 2 as probability is equal to 1/2, and just sum of this value would be the correct answer. Computing these values is a standard application of any data structure. For example, it can be done with binary index tree or segment tree in n log n time, which is enough for solving this problem. That's all.